Hello once again to the Coronavirus Daily. This is the peak of Indian summers, and depending on the self evaluated risk factor, people are discussing whether switching on ACs is a good idea or bad. For the first time in the history of humankind, that decision isn't based on impact on electricity bill, but a life or death issue. My name is Ajay Punya, and this is episode 50. As action by the public is key component to disease control, it is important that the public be kept in the loop and made to feel like they are on the team. Well, since the government doesn't think so, at least we can be on each other's team. The date today is 24th May, and it will be a short one, but a one full of reality checks, since reality doesn't care whether or not we believe in it, but happens to be really very useful for all of us when we understand it. On some days, the government feels like doing a press conference because, some shandemic is going on. So they think perhaps people should be informed of what is happening. Well, thank you so much. And in such press cons, the government throws some data which suits their narrative. Like a couple of days ago, they said over 80% active cases are in 5 states, 90% in 10 states, 60% in 5 cities, and 70% in 10 cities, which they translated as spread of infection confined to certain areas only. So let's explore this topic. By now, you must be familiar with R naught, that is, each infected person can, on average, infect how many others. The important point here is on average. You must have also heard of the concept of super spreaders like the dormitories of Singapore, the pubs of South Korea, meatpacking plant in US, and other such. Sometimes a single person infects dozens of people, whereas other clusters unfold across several generations of spread in multiple venues. This establishes the distinction between the terms infected and contagious. In the case of COVID-19, most people who are infected do not infect anyone, while some people infect a lot of others. How uneven this distribution is in the case of SARS-CoV-2 is still unclear. In the case of its two cousins, SARS and MERS, they weren't extremely confined. There is a term for it also. It's a dispersion factor denoted with K, which is a measure used to quantify whether a set of observed occurrences are clustered or dispersed. The 1918 Spanish flu, for example, had a K of 1, meaning clusters didn't really matter much. MERS had 0.25 and SARS had 0.16, meaning these two were highly clustered. In Singapore, 73% of SARS infected people infected less than one person, while 6% infected more than 8 people. At this point, we don't know what is the K of SARS-CoV-2. One paper, however, by London School of Hygiene and Tropical Medicine scientists estimates the K to be as low as 0.1, meaning 10% of infected individuals cause 80% of the transmissions. But we don't know who these people are, and it's highly unlikely to be able to find them out. And if this does actually turn out to be true, then it also explains why the virus did not take off everywhere soon after it emerged in China, and why France, where cases were detected in December, failed to ignite an outbreak. Moving on, with a little bit of luck and a lot of science, as I will explain in detail later, we will get a vaccine in a not so distant future. But before that happens, wearing a mask will become as normal as, say, carrying a cell phone. A friend's sneeze will not be followed by bless you, and the case for public transport will become weaker. And now it is amply clear we are not going back to how we were for a while. In this period, we can expect and be prepared for the various ways in which the coronavirus waves will hit us. As Stat News explains, and that there are 3 likely futures. In one future, a giant wave will hit us in the early mid-2020, the one that we're currently going through. And then there will be mini waves of smaller outbreaks every few weeks or months. This small rise and fall reflects an emerging consensus that this coronavirus has some seasonality but will not be eliminated by hot or humid weather. In this case, people continue to maintain healthy habits, and there will be mini outbreaks time and again, with stricter measures followed every time there is an outbreak. in the second future. The current giant wave is followed later this year with a much bigger wave as rise in temperatures makes people put their guard down and are caught unprepared. In this scenario, instead of a wave like scenario, we continue to have a constant case cliff as fatigue with voluntary or mandatory lockdown sets in as we let down our guard and a gargantuan second wave washes us over, taking the health system down. And a third one, where wave like the ongoing one isn't a wave but a new normal that continues till we have a vaccine. December 2021, if we're lucky, or December 2022, who knows? It'll be like a perpetual Groundhog Day scenario where outbreaks keep happening in one city or the other and the authorities keep trying to crush them. No plans can be made without the rider of last minute cancellations owing to an outbreak. That'll be a bummer. But what do we know about the three scenarios is that COVID 19 is not going away anytime soon. That's because even if some do, but not everyone will have immunity to the virus. Since sufficient population does not have immunity, the virus will keep finding new victims. As countries decide to ease lockdowns, amongst the many yet known unknowns of the pandemic, and it's a very heart-stopping one, especially on the day New York Times put out the names of 100,000 people who died in the US. The biggest question is, how many deaths can a particular country, city, or community tolerate? Life will be a constant balancing act of the impossibility trilemma to keep cases and deaths low, to preserve jobs and economic activity, and to preserve people's emotional well-being. Right. So, in the last couple of episodes, I spoke of what are the various kinds of vaccines that are currently under works and what are the various stages of development of a vaccine. Thus, I thought it's a good time to talk about the status of these vaccines, especially the ones that are in human trials. I'll just jump straight to the climax and then I'll tell you the story in flashback. It looks murky, it doesn't look promising. Let me tell you how. America's darling Moderna's mRNA 1273 vaccine completed phase 1 of human trials and published a press release of its early success. That got its share price go north, so their vaccine triggered an immune response in people and protected mice from lung infections with the coronavirus. But the thing is, it is only a press release, and like I said in the last episode, investors are keen listeners. They haven't published a detailed data so that other scientists can review and evaluate those claims. But what we do know is that only 8 people were the subject of the study and was designed to study safety and not really efficacy. But FDA, a couple of weeks ago, already gave it permission to move into phase 2 trials, which will begin shortly. And phase 3 trials will begin in July. You can check out the last video to understand what is the meaning of phases. Next up is the Oxford University vaccine. With their partnership with AstraZeneca, one good thing is that they've changed the name of their vaccine from Chad OX1 nCoV 19 to an easy to recall AZD 1222. Their vaccine protected 6 monkeys from pneumonia, but the animals' noses harbored as much virus as did those of unvaccinated monkeys. Basically, it could not stop them from catching the infection. However, these monkeys were given much more virus than humans are likely to be exposed to. So what does it mean? It means that the vaccine can reduce the severity of the infection but is unable to prevent the infection completely. In April, however, Oxford scientists had said that the vaccine was showing promise in monkeys. Promise. Guess it was a promise unmet. Then there is the Sinovac biotech of China. Well, they seem to have elicited a more promising antibody response in macaque monkeys that received 3 doses. Their vaccine induced SARS-CoV-2 specific neutralizing antibodies in mice, rats, and rhesus macaques. They've started with phases 1 and 2 of their trials with a total of 744 subjects. In the hunt for an effective vaccine, there are quite a few known unknowns, like the precise nature of the immune response that protects people from COVID-19, the levels of neutralizing antibodies needed, whether vaccinated people still spread the virus, and how long the immunity will last from the vaccine. So, it looks like the work on vaccines can help to some extent and get by with it. But we're going to need to improve on them to develop second and third generation vaccines. World over, there are over 200 vaccines that are being developed, including in countries like Norway and Thailand. GenN News has created a wonderful section dividing the candidates into 4 categories based on their development and clinical progress. Front runner, definitely maybe, keeping an eye on, and too soon to tell. The curious ones amongst you can check it out. I've given the link below. Right, now for something new that I'm trying for the first time. In the last 20 days since I've been missing, I've got quite a few questions from people who for some reason thought I can answer their questions around the coronavirus. Well, I'm neither a virologist or an epidemiologist or infectious disease specialist, but I read and I like to be updated. So let me try my hand at answering some of the interesting and important questions. And honestly speaking, I've taken the liberty to frame the questions to give them a proper structure. Right, so the first question that I got was, is the optimism of the world's infectious disease experts and politicians based entirely on the fact that there are so many resources that are dedicated towards it, which is why this time it is different from, say, SARS and MERS? Well, that's partly true, but there are reasons to believe it is only a matter of time and not if, because we know the problem, we have the tools. In fact, as I just explained, we have quite a few different tools, and we have the desire. For SARS and MERS, funding actually stopped as soon as infection stopped. And it seems unlikely SARS-2 would disappear in thin air. Don't hate me for saying that. So even if we get effective drugs soon to reduce the severity of the disease, finding and treating such a disease is much harder than prevention, as by now you're all familiar with. Right, another question. If a vaccine leads to achieving an immunity level equal to the antibodies achieved by an infection itself, and over a period of time we will anyway achieve herd immunity, then why do we need a vaccine? Oh wow, that's an interesting question. It's a question that's certainly coming from an optimist. There are some people who don't recover. I'm sure you've been keeping track of that. And what happens to those who don't recover? They die, which empathetic individuals like you and me consider to be a bad thing, is it not? So in India, even if one believes the official data of low infection fertility rate, when you convert the rate into absolute numbers, we arrive at numbers running into millions. So let's not bet on herd immunity. Okay, one more question. How can we confidently say that the COVID-19 vaccine will come, especially when there is no HIV vaccine? I think I've addressed part of it earlier, but I'll sort of expand on HIV. That's a question, though, that's outside the domain of Coronavirus Daily, but it's a question I see often online. So, HIV is a very special virus, and as I mentioned in an earlier episode, SARS-CoV-2 isn't that complex. HIV marks its presence in our DNA. Coronavirus, on the other hand, leaves its code on a tissue paper that dissolves without a trace once the immune system stops them from copying. A simpler way to understand this is that even though it's a new virus, it still is a virus that plays by biological rules. And so, even if a vaccine may not protect our nose from which the coronavirus finds its way inside our body, the vaccine can at least protect our lungs and maybe, just maybe, turn COVID-19 into a manageable cold instead of pneumonia. Right, that's all for today. If you like the episode, please do subscribe the channel and share this video. Goodbye, wash your hands, and see you later.